So we are here in GPS, which is the usual Ada development environment, and I have a version of the Tetris game here that's extremely close to the one that has been ported already on the SAM 4S and the smartwatch. You can see those ports in the Ada core blog. You can see here there's the core Tetris game, which is in Spark, which actually means that I can prove it, and this very version has been proven free of runtime errors, and actually the implementation has been checked against a number of properties. So this is a very strong kernel for the game, and I know that it's exempt of all kind of nasty bugs. Now, what I'm going to try to do here is to export this core game into a game engine which is called Unity, which is a game engine very well known from the indie scene. So in order to do that, I'm going to need to be able to export this code somehow into Unity environment, and in this very case I'm going to use C# as a platform. So to export the component of this game into C#, I need first to export it into C, and I'm going to create a little wrappers around the functions of this Tetris core game. That's what I'm doing here in this game loop package, except for this cycle procedure, which is a bit more comprehensive, which actually implements one step in the game, if you will. All the other functions are just wrappers, and you can see here that I'm exporting those things in the C convention. So from the C# perspective, it would be exactly as if I'm importing something coming from C. You can see that I've set the external names for all of this in order to know exactly what is the name format that's going to be represented in the object file. One important thing to keep in mind when doing that, if I go to get kind here, you will see in each and every of these wrappers this little exception handler. The reason is that there isn't really a way to retrieve an Ada exception within C#. I would need to do some kind of a conversion at that level. If you don't retrieve exceptions here, and there is an exception that gets unhandled, it's going to crash the entire platform, and this is quite an annoying behavior. Of course, the Tetris game itself is free of exception because it was proven against Spark, so I know that there cannot be any problem in the core engine itself, in the core game itself. But at the interface level, there's no such check, which is the reason why I need those. Anyway, carrying on, you'll see here that I've got the code for the cycle, which, as I was saying, is a little bit more comprehensive, and then a bunch of other stuff that are being exported. Now, we are going to look at what that looks like in the C# code. So I'm opening this environment here. Now I am within Visual Studio, and I'm going to import various subprograms that have been declared and exported in Ada. And the idea is that this Ada code that you saw before is going to be compiled into a shared library, which is then going to be loaded by Unity. So you can see here it's actually quite simple. It's surprisingly simple for anybody that has done interfacing with other virtual machine-based languages such as Java. You declare here the name of the library from which things are being imported. So here it's Tetris, and then the proper profile for the function. So if I take Tetris cycle, there's no parameter, there's no return value, so that's obviously a void function with no parameter. If I look at this get kind subprogram that we saw before, here, getting back to the specification, I see that x and y are expected as integers, and then I'm returning a cell type, which I know is going to be mapped into an unsigned int, a small unsigned int, which corresponds to a byte in C#. And you can see that here the import is using this same mapping, so byte as the return type, and it x and y as input. One feature that I quite like when interfacing with C# is the fact that you can actually map data structure by value, which is I don't think is even possible in Java. So for example here, sorry, I didn't mean to do that. Here in the here care piece, that's the one I was looking at, I'm returning this piece type, which is a record comprising a number of fields. And again, because I know a little bit about the implementation, I know how that's mapped onto memory. If you don't, which is the most common case, you may want to specify specific representation with program convention C and so on and so forth. But nonetheless, I have this record type here, which I'm directly mapping to a struct in C#. And basically, I know here that S and D are mapped into 8-bit unsigned integers. X and Y will be mapped onto regular integers. And that corresponds to the declaration of this structure here, which I can reuse directly when interfacing Tetris getChar piece. All right, so now that I have all these functions that have been interfaced, I can develop the behavior of the game. This class here is called a mono behavior, which is what Unity is using to describe behavior associated to object in the game, or scripts, if you will, associated to object in the game. It contains a number of special functions. One is called awake, which is called straight after the object is set up. Here what I'm doing is that I'm retrieving a handle on this resource, which is called cell, and you'll see how it looks like straight after. And then I'm going to instantiate this resource many times through this instantiate call here. The idea is that I'm going to pre-instantiate a grid of cell in order to display the Tetris. Okay. Later on, I'm going to hit this update function, which is going to be called at every frame of the game. And here I'm doing various stuff. In particular, I'm going to say that if I wait enough, then I'll call the cycle function from the Tetris in order to make the game move one step. And then I'll refresh the graphical environment, which, as you can see here, consists in getting the kind of various locations and deciding if the cell is supposed to be active or not. In other words, if the cell is supposed to be visible or not. And that's basically the main idea behind this integration and implementation of the Tetris, at least at the scripting level. There's a few things around that is not worth spending too much time. And without further ado, let's dive and look at the actual Unity environment. Okay, so this is Unity. So that's, as I was saying, a game engine that is actually freely downloadable. You can get it from the Unity website in order to try this out and do other things. Actually, let's start to look at what the game looks like just by clicking on this play button. Okay, so that opens that launches the game in the game view, and you can see that there's this little piece that is going down. I can move it left or right with the arrows, the left and right arrow, and then if I press up and down, I'm going to just change the orientation, and if I hit space, it's going to bring it down to the bottom. Now, I'm not very good at Tetris, but I'm going to try to do a whole line to show a little bit of an animation that was developed for this version of Tetris, just when the line is being finished. I think, no, it's not going to work here. Let's carry on. Really would like, okay, that's going to be good. Actually not quite. Yes, as I was saying, Tetris is not my forte, but let's try to run. Okay, that should work, shouldn't it? Yes. Okay. Now when a full line is being destroyed, I have this animation which is based on Unity particle systems, and that shows a little explosion on the line, which is a little addition if you compare to the previous ports that were done on this Tetris core. Let's look at it again. Yeah, and these things are extremely easy to do in Unity. So let's see what we have here around. Like, first of all, within Unity, I can actually debug the scene and introspect what are the contents. And this is the game view, but I can move to the scene view, which going to allow me, and let's move to the 3D perspective, to look around what's happening in real time in 3D. And I can see actually these pieces that are carrying on falling down here. So that's extremely convenient to understand what's around the game as I'm developing it. I'm going to pause it here. You can see here that all the objects of the game has been created. So those explosions that you see, they're still laying around, and all those cells, those that are deactivated, see like here, they are deactivated, and those that are activated, and that corresponds to objects that are displayed in the scene. And I can change this thing live from within the editor if I want, which is extremely cool. If I click on this cell, I know where it is, and I can just display it over there by clicking on this button, and I can just hide it if I click again. Unity is following a component-based paradigm for the design. So all of these elements on the left panel here, they are called game objects, and they are composed of various components. So a cell, for example, here is composed of a transform, which decides the position, rotation, and scale of the object, a mesh filter, which decides on the shape of the object in 3D, a collider, which actually I'm not reusing, so I could remove this one, a renderer that works on how to render that shape on the screen, and then here there's a script. You could actually associate a cell or an object with a number of scripts which are derived from this model behavior that we saw earlier. And again, I can change these things live. Like for example, here, if I'm not happy with a cube, I can click here and say, actually make a sphere, and that's it. I've just changed this object into a sphere. Now, some of these objects are static. They are set at startup. Some of these objects are dynamic. They are created by the scripts. If I stop the execution, you'll see that all the dynamic objects disappear. So remember, like here in the Tetris game, I was creating dynamically instances of this cell object, but they were not part of the initial environment, so that's why they don't appear anymore. Actually, those objects to be created dynamic, they are called prefab, and they are located into a resource folder within your assets folder here. So you can see this cell object here, cell.prefab, which is the one that I'm instantiating, and I can modify it or create another one from right here. So for example, if I decide that all of the cells to be created somehow need to be spheres instead of cubes, I can click on this cell here, and I'm modifying the prefab to be a sphere. And if I relaunch the game now, as you will see, I have little spheres instead of having little cubes. Interestingly, just a side note, you see that the second time I relaunched the game, it was already set. The reason is that the dynamic library is actually linked to the Unity environment, not to the game instance, if you will. So if I relaunch the game, the state of the library at the previous game launch is reused for this game launch. And by the way, this leads me to introduce you to a second special directory in my assets, this plugins directory, which has to contain dynamic libraries that I want to download. So here I have this Tetris DLL that is the result of the compilation of the Ada code that you saw before, that I placed here, so that when I do all of this DLL import statement, Unity knows where to get those from. It knows where Tetris is located. It is in this plugin environment. And this is pretty much what I wanted to describe and what I wanted to show here. So once again, the idea is that we are integrating Ada and Unity through C# in order to allow to develop a very solid and strong game kernel directly in Ada, and then port that onto a more advanced graphical environment.